Hello, and welcome to this video. In this video, we'll take a look at kickstarts and how they affect your installs, whether you're doing a manual install or a kickstart install, and we'll see the advantages of using kickstarts, which is what gives Cobbler such power. Here we have an install that we're going to do using virt install, which is what will also be used by a cone install, which will kickstart. The script has been manually created, giving the MAC address and the other network configuration parameters for the virtual machine, the disk size, the CPUs, the RAM, all of that. And just to break it down, we have virt install, which is the command. We are building our builds machine. RAM is 8 gig. We have 4 CPUs. We'll set it up for VNC. The virtual type is KVM. The machine is PC. Architecture is x86-64. Our OS variant is Red Hat 9. It has a disk with this path. The size is 256 gig. And the format is QCOW2, the QEMU disk format. We have a network interface. It bridges to bridge 1 with the MAC address defined here. We won't wait, we won't do a console, and we'll do an install from the CD-ROM image. Or I guess it's actually a DVD image, but anyways, we'll go here. This shell script is builds.sh, and as I said, it's manually created. So we'll go here. Permissions, so. And let's note the time. 12:22. Oh. Red Hat 9 does not exist in the distro right now. So we'll tell it that it's actually Red Hat 7. It doesn't really matter too much. So we're starting the install, and the install is going at 12:23. And we'll tell it to go straight to the install rather than to sit there and check the image, because it's already been checked a number of times. Now we got to go through and adjust our window size. Wait for it to boot, which you have to do anyways with a cone install. But we'll soon be to the point where a cone plus kickstart install does everything automatically for you. Okay, 12:24. Here we have to select the language, excuse me. And we'll notice here the typical installation summary screen. Now here we've got local media, soft server with GUI. I actually want a minimal install because we'll install everything on top of that. And partitioning, we'll get to that in a minute. Actually, it's the root password, not the root user ID. set a temporary password. We're not going to lock it. We're not going to allow SSH login with password because we'd have to resecure that later on. We got that done. Now here, we got a disk. We want to do a custom install. And we have custom install. And we'll go here to full disk summary, see what we have here, a 256 gig disk showing up as VDA. Now, custom install will take us to this screen. Now, there's nothing there right now. We'll create them automatically as a quick starting point. Now, homes, I'm going to get rid of it because I get my home directories from an NFS server. A root of 70 gig is too large, and I go with a root of 8 gig. And update the settings. Boot of 1024. That's good. Swap. I like a nice round figure. I'll go ahead and do 8 gig here. And update. Actually, with this, we need some more. So we'll start off. I do a separate user. Now, there are folks who will go on about all the hassles of this, but there's one reason I do a separate user. If I go to install software, I don't stand to encrypt certain files on the root file system if something else goes on. So we'll add an 8 gig root. Next, we separate out temp, and its size will be, checking over on my spreadsheet on the other screen, 4 gig. And we've got root, user, we've got boot. I want a 32 gig opt and a 16 gig var. And I don't know why they say that opt is data, because software gets installed there. I would have included it. And notice we're at 1229. I don't display the seconds. Darn it. So we're at 1229. We've got opt, we got root, temp, user, var, boot, and swap. And we've still got 178 gig left, which we'll use for other things after we build it. One thing I want to do is I want to rename this, and I follow this so that I can actually take an image and move it over to another machine and mount it without colliding on the name. So all that's updated, everything's set. We click done. It'll ask us to verify, accept the changes. And we're now at 30. So at this point, we'll tell it begin installation. Now at this point, we're doing what we would be doing on a install irregardless. So I'll let the install proceed to go forward. And once it's done, we'll edit out this portion of the video and get to the steps that I have to do afterwards, because it's not a Kickstart install that can do these for me automatically. Okay, that was quick, and it is now 12:35. So 5 minutes to do that. Part of the reason I do a minimal install is that from there I can install whatever else I want. So we'll tell it to reboot the system. And we will go ahead and check the parameters here. 4 CPUs out of 32 for this machine, 8 gig, and storage size is unknown because it hasn't booted yet. Now this machine, we will want to go ahead and have it auto start. And we'll apply that. And we'll tell it to go ahead and start. And okay, here's where things get fun. I need to copy over my SSH keys. Let me pop over to okay, edit that out. We got to copy the file into place. I've done that over on yes, because it can't be helped. Enter my temporary password, which I'm using. We've got this, and at this point, we've got Things ready to unpack. CD/. We got to install tar. Again, this is something that could be handled by the auto install. And this will take a minute. Yes. Yes. Now we can do this. Now we can do this. And I'll bring this window over here. We'll need to create the directory first. It already exists. Oh yes, I can't use the password. So I can't do it that way. Silly me. So we're here, and now we should be able to and we can. There will be some other initialization that I'll have to do, but right now we have what we declare to be an initial system load. That enables me to manage things. And we can add a snapshot. The reason I added a snapshot here is I can always come back to this point and go from there. So that is it for this part. I'll be running the other script, which I'd be running anyways, were I to do a kickstart install. So time consumed right now is 12:44, so roughly 14 minutes. 5 of that was done automatically for me. So figure 10 minutes additional time spent that I could have been doing something else. So that's it for this part. Okay, for this section of the video, we're going to look at how Kickstart files can make it so that Cobbler can direct a install and make it much simpler for you as a user and make it quicker. No entering data manually or anything like that. In our previous install, we didn't use a kickstart file at all. And in this one, we'll use a kickstart file that was generated by a previous install and modified from there. And here is our kickstart file. We start off with some headers here, and then we say we're going to use a graphical install. This could just as easily say that it would be a text install. We want to enable our kdump facility, so this is what this add-on block here does. And as you may remember, when we were doing the install straight from the CD with no kickstart, we were first prompted for the keyboard and for the language. Here they're specified, and it makes it much simpler. You don't have to go through and drag the mouse around or anything like that, scroll down to find it or anything. You can specify it directly. Now, this part here defines the packages that we're going to install. We're going to use a minimal install, and because this is going to be a Rocky Linux as opposed to a Red Hat Enterprise Linux itself, we need to install tar because tar is not included on the Rocky Linux minimal installation environment. And we'll use that here a little bit later on. And so we've got the packages here. And with Cobbler, I actually use a variable on the system to say what my server is going to be doing. So am I going to be wanting just a minimal install, or do I want a web server install, or do I want a full-blown desktop environment? And I define package snippets that are included in place of this, and replace an include statement with the packages, the list of packages in the end. And I've got some of these that are fairly long, cleaning out some of the various packages that get installed, along with adding others in. For example, wireless drivers. If I don't have a wireless card, why install the wireless drivers? It just chews up disk space. So that's one of the handy things about those snippets. Here we'll define our network. We'll use DHCP on this interface. We want it on boot. And here's our host name. And this can be templated as well so that the ENS3 and the builds can be a couple variable substitutions. And I could wrap this in an if statement with Cobbler templating, but I'm not doing that here since I'm not using Cobbler. I'm just injecting it directly. A moment on that last point. Why am I not using Cobbler directly? I'm not using Cobbler directly because right now the support for Red Hat Enterprise 9 and its change on the kernel arguments has not been incorporated even into the development branch. It's sitting on a pull request. And rather than have yet another pull request in my environment for Cobbler, I'm just waiting for that to be finished up because I don't know how well that works right now. But back to the Kickstart file, we've got our first boot and we've got it disabled, so it's not going to ask us for various information there at the beginning of the boot on its first boot. And then we come to a real section of meat. If you remember on my previous install, I had to go through and I had to define the various partitions to partition things out. Now I didn't do a UEFI install, so I didn't have a couple of partitions that were defined. And I went with a much simpler install, so I didn't have some of these other partitions as well. But here I say I want it to ignore the disks and only use virtual disk A, VDA. I want it to clear the partition table, keep none of them, and initialize the label. I want to create the BIOS boot partition, which is required for UEFI. Create the boot partition, which every Linux box will have, to put the kernel in the initial RAM disk into, so that it can then proceed to read LVM and what other file systems you have, and boot EFI. Next, we come with our physical partition on the disk that is going to support our logical volume manager. And we define the volume group on that. And then we have our logical volumes for user varlib Jenkins, varlib Docker, temp, var www, swap, our root file system, and var. And then we define our time sources and our time zone. And we have this here, which I've edited in this instance, where it specifies the root password. Now, this is something that gets copied directly into your shadow password file, but to make it secure, I have it commented out with various information. You know, this is some crypto salt, and this is some encrypted data which makes up the passphrase. So, and then I tell it to reboot when things are complete. And here's one of the other nice things. After you've defined all your Kickstart statements, you can add in pre-install and post-install scripts. Normally I'm using a pre-install script to generate this partitioning information, but since I'm doing a special setup for this machine, I just hard-coded it in there manually for right now. I'll have to enter it into cobbler manually later on so that I could actually use the Python. It's actually a Python script that I use to generate the partitioning. And I've not had a chance to test it out on Red Hat 9 yet. But we have a post-install step here. We'll make a directory temp kickstart that's under the change root environment. So that's going to be temp kickstart on the installed system. And we go through and we do some networking configuration. And we set up our interface configuration file, type Ethernet, boot protocol is DHCP, and then that. And then we go through and we do some additional cleanup, and that's done our network configuration. I'm also going to disable IPv6 for this machine right now, because Jenkins has a repository, a mirror that doesn't like IPv6, which I keep getting when I do my queries. And so I want to make sure that I'm not trying IPv6 and getting timeouts when I run the playbook. We create a resolve.conf, and here we get information from one of my servers for the SSH config files so that it's automatically known by the system. And we put the key files into place onto the SSH config directory. And we also pull over our authorized keys files, and that's a snippet that I normally do an include, but I've manually included it here. And then we end the build kickstart file. Now, how long does this take? Well, you saw before it takes me 10 minutes to just manually enter that information. It's 3:25. And when it hits 3:26, we'll go ahead and hit return. So here we are, and it's running the install, so I can pop over here. And I'll drag this open and over so that you can see it. And you'll notice we don't have any of the prompting that it did before. And we're installing roughly the same amount as we were installing before. Just one or two packages, but here it's automatically filling out the information and we're off and running. So already we've saved ourselves more than 10 minutes in the first minute. So as this chugs along, what is this server going to do? I'm going to have it install Ansible, or install via Ansible the Jenkins server, so I can use it for doing my builds. And Jenkins is a really nice utility for doing that. I can run software builds, test the builds and everything. I can even have it build containers for applications. Like I could have a application that serves up my resume, which I'll be adding at some point here, just as a looking at what I can do. This is a sample of my work, and I'll be putting up an app using a container for it, and I could actually push the container out and have it run another Ansible playbook to have that container loaded on the web server. So as we're setting here, you may have noticed it had a file name IW, and that's a wireless web driver, a wireless Wi-Fi driver. Why do I need those? This is a virtual machine. It's got no Wi-Fi. It's all essentially a physically wired internet connection. So as I go forward, I'll actually trim that listing down from the minimal, and I'll say minus this package, minus that package, minus this other package that I don't want, don't need. And again, that can go into a snippet that I load in, and it becomes a part of all my installs for Rocky Linux 9 or Red Hat Enterprise 9. So right now we're 3 minutes along, almost 4 minutes, I figure. It's configuring the kernel now. And some of these will go real fast. Okay, we're generating the initial RAM disk. We are now approximately 5 minutes along, and it's finished the installation. So 5 minutes, and we cut out to 10 plus minutes worth of time filling through the menus. So we'll go ahead and create a checkpoint. My initial system load. And we'll start it up. Have to start it because even though one of the first things I do is I shut it down and go back to that checkpoint, it wants to probe the system. So here we'll go dash playbook builds.yaml. And it's 32. And there it's going back to the snapshot that I just created. It's booting. And we start by enabling the EPEL release and the CRB. I need to modify the roll so that it turns off that warning. But install some dependencies. It's setting up my AutoFS directories. The known host file. Because I define all my known hosts in a single file with their public keys and copy that around so that I don't have to dynamically create it on machine B after I've already done it on machine A. So we're going through here, telling it to use SSSD. ID map D is getting configured, LDAP. We're now upgrading all the packages. We've got the Jenkins repo established and the repo key imported. And this will take a moment. One of the longer steps of this whole process. But notice, here I am. I'm doing no typing whatsoever. I'm just sitting here. Other than running the Ansible playbook, and setting up the snapshot. That's all I really do manually on this process. And the reason I set up the snapshot manually is I can actually, if I want to change the playbook and the role that I'm running, I can go back to that same point and start all over again and go further and further. And that's how I've developed this role. I started off by upgrading all the packages and using existing tasks that set up the SSH and the SSD so that they are set up properly on my machine. But hands off, I can go get a cup of coffee, except for I don't drink coffee, or my favorite beverage, water, and just wait for it to complete. And I'm doing that mainly because if I watch it, it'll take longer. The old watch pot never boils adage. I just took 5 seconds off of it. But once it finishes this, it'll install Jenkins, it'll install Docker, or rather Podman, since that's what Red Hat Enterprise 9 is using now, is Podman. And it'll automatically do the firewall changes and everything else, as we'll see here in a minute. We are now 11 minutes in, and I've only typed a couple of times. Okay, it's installing the JDK. And once it's installed the JDK, it'll install Jenkins, and then it'll install Docker, and then it'll do the various jiggery pokeries that you have to generally write little post-it notes for yourself to remember how to do. But while we're waiting, let's recap what all I've typed. I've typed the command to start the actual install. Here we go, we're installing Jenkins. That also meant I needed to start up this terminal console session here. I didn't have to, but it's nice to see it do its thing. Well, actually I did, because I needed to do the snapshot at the end of the install and know when the install finished. Now I could actually set up things once I get full integration set up. I could set up a notifier script that hit a certain URL on a machine that would then trigger the Ansible playbook. And I could actually have it assume at that point that I needed to create the snapshot. But starting the install, firing up the console. Once it finished the install, creating the snapshot and starting the machine, and starting the playbook. 5 times that I've touched the keyboard. And here we are, we're reloading and starting Jenkins. And we can log into the machine. Drag over browser. We'll reload this. This was from the previous run. And I'll go over here on the other screen. Jenkins secrets. continue. And as you can see, we're sitting here. I'll install the standard plugins. And where are we in things? We're 42, so 26, 42. We're 16 minutes along. And I'm already setting up my Jenkins server. And here we've got our information. I'll just go ahead and real quickly drag that off screen so that I can and we've got our URL there, save and finish. And we're done. And 18 minutes. So that's what Kickstart can do for us compared to before when we were talking this long just to do the base install. And you've seen here how Ansible helps automate a lot of this as well. And that is the whole principle behind using Cobbler and Ansible and Kickstart and all these technologies together, is to produce a very quick, minimal typing for minimal mistakes build. So that's it for this part of the video. Be sure to press the like button below, subscribe, and let me know what you thought of this video.